Hello everyone, in this lesson we're going to cover approximation. So we're going to firstly cover significant figures, then we're going to see what upper and lower bounds are and how they work. Then we will talk about percentage error, and then I also have concluded one exam question to make sure that you understand the topic. So let's start with significant figures. In IB exams and also in TUI's test papers, it is said everywhere that you have to round to 3 significant figures. What this means is that you just have to give your answer with the 3 most important numbers. It may seem easy at first, however, it's actually quite complicated, and this is one of the reasons why I have lost a full 7. So, to go over it, 3 significant figures, as I said first, is the 3 first numbers. So you have to round numbers and then just choose the 3 first numbers that you get. So if we have numbers, for example, like 1.4876, then you just round to the 3rd decimal place, which is over here. And you get your answer to be 1.49, and that's your total answer. However, it does get a bit trickier after this as well. So let's say that we're looking at huge sums of money and you have numbers like 50,823, and you're now wondering, how do I give this in 3 significant figures? Therefore you do the same thing, you just choose the first 3 numbers and then you look on here whether you have to round up or you stay the same, and here you see, because it's 2, it doesn't round up, so you have to give your answer to 56,800 euros, and you completely wipe out the rest. Even if they are a full number, you still don't include them because you will lose points because of this. Another factor that you might be wondering is, what if we have a very small number? So let's say we have a number like this. Then therefore you just start your 3 significant figures start first when the number starts. So therefore you can see that this is worth 2.27. And yeah, so if you're looking at very small numbers, you have many zeros on the front, the 3 significant figures that you have to write down starts when the first number that isn't 0 starts. That's very important as well. A lot of you are wondering that what happens if your final answer is something like 0.7, and many of you are wondering that what happens if you get your answer to be like 0.6 exactly, and it's very reasonable that this is not 3 significant figures and you have to rewrite it as 3 significant figures. Therefore you have to put a note to the end to make sure that you have the whole correct 3 significant figures, which gets you the full marks. And that should be about it for this as well. And yeah, also some small tips as well. If you have a number like, let's say 0.702, I just did past exam that had like this, then even if the 0 is in still middle, if the 0 is in the middle of a number, it's still considered as a significant number, and that is your correct answer, and you don't have to round this anywhere else. So keep in mind. So let's also go over upper and lower bounds. In most exercises, when upper and lower bounds are given, they are most usually written as something like something is measured, and then it's written that it is measured to the nearest centimeter, or like meter, let's say in this case. And upper and lower bounds are actually quite easy. A lot of people overcomplicate them. What you have to do, you have to understand the measuring point. In this case, it's the nearest meter. And what you want to do is you want to just take one of the meter, because if it says to the nearest meter, it's obviously to the nearest 1 meter. And then you divide this by 2 and you get your difference to be 0.5. And if you want to find upper and lower bounds, let's say you're given that the bridge per se bridge is 501 meters tall, and then after that it said that however it is measured to the nearest 1 meter. Then if you want to find the upper bound, you just add the difference that you have from here, which is 0.5. You add 0.5 to your bridge height, which was 501 meters, and you get your upper bound to be 501 times 5 meters. And if you want your lower bound and you want to also find this, then it's just the same thing. However, now you take your bridge, which is 501, and you subtract 0.5 from it, and you get that it's 500.5 meters. However, I also have to bring out that in many cases it's not just 1 meter or 1 centimeter or 1 kilometer. Sometimes it's also written as something like to the nearest 10th of a centimeter. This is one of like scenarios that it can also be done, or like 1/5 of a scenario. So always, depending on your situation, you have to take the full context. So if here is 1/10 of a centimeter, then you obviously divide 0.1 with 2, and you get that it's worth 0.05. And then you can add this like on top, or subtract it from your amount that's given, and therefore you can find the same way. It's just a small reminder that in most cases you will not be given it as just 1 meter. It will be given something like this, like to the nearest half of a centimeter. Then you can also write here 0.5, and this is the case for many paper 2 exams where they want to see if you know the difference, how to actually find upper bound and how to find the lower bound, and therefore you will have like additional exercises where you have to calculate these and see the total difference and then conclude something. And the last thing that we're going to look at today is the percentage error. Don't worry, this is also given in your formula booklet right here, and it essentially says that the percentage error is equal to the value, the approximated value minus the exact value divided by the exact value times 100. So this is actually very simple. I think in many real life cases you also have seen this. It's percentage error is mostly used when you see in paper exams as well, or exercises as well, that where something is done, like it's something is found that the height of a person is like 1 meter 70 tall, and that's approximately, it's like people just looked at it. However, then he's done the like people have measured him, and then it's found out that he's actually 175, and then you calculate how much it was different as a percentage. The reason you might see this black I guess you could say them brackets, I don't know what their exact name is. However, this means that your answer has always has to be positive. Yes, everyone is aware that the difference can come out negative, meaning that it's actually smaller. However, percentage error is always positive because it goes up and down as well, meaning that the percentage error has to come out in a non-negative form, meaning that it should always be positive. So this lesson is actually quite easy. So to top it all off, let's go also look at the exam question as well. So Saha is designing a bridge to cross a river. She believes that the weight of the steel needed for this bridge is approximately 53,632,000 kilograms. However, the weight exactly needed for the bridge is 55,625,000 kilograms. So the first question states that find the percentage error in Saha's approximation. Then you can just type in the formula. I hope you have remembered this because we just talked about it. You know that first goes in the approximate value, which is around 53 million. 53,600. And then you minus this from 55,600,000 and you divide this with the exact value, which is 55. Yeah, that should be about it. And of course you gotta get the brackets in and also time it with 100%. So we can go to our calculator. We can 53,632 million minus 525 million divided by 55,625 million, and also time it with 100%. And as you can see here, the answer comes out as negative. However, this is how IB gets you, and since you know that the brackets mean that it always has to be positive, then you can just write it down as the answer as 3.5829%, and you round this to 3 significant figures, which is equal to 3.58. So in the second part, it states that Saha's design is used to build 5 identical bridges. So the first part asks that find the weight of steel needed for these 5 bridges. So obviously we know that there's needed the exact weight, and it said to 3 significant figures, something that we just talked about. So we take our number, which is 55 million, times 55,625,000, and we multiply this with, was it 10 or 5? I think it was 5. Let me check. Yeah, 5 identical bridges. 55,625 times 5, I think that's correct, and you get your answer to be 278, and that should be around about it. However, the problem with this is, I just talked about it, that even if you have full numbers, it still has to be 3 significant figures. So your answer comes out to 278, and everything else is just null. That should be it, yeah. And it's kilograms as well. And the second question states that write down your answer in the form of a scientific form. This is something that we already know. So clearly you have to write down first the numbers that you have. So the numbers are 2.78 and to the power of, and then you start to think how many I did a mistake here, my apologies. And then you understand that it's powered to the 8th, because 10 to the power 8 should be 100 million if I'm sure. Then let's calculate this. 2.78 times 10 to the power of 8, just to make sure. And if we write this number besides it, it should be the exact same, just to make sure that we don't lose any accidental points. And to cover it all up, I'm gonna write B here and B here as well. And that's the whole lesson that you should know about approximation. Thank you.